Hi, I'm Sabrina. I'm going to talk about MaxX today. So what it is, why do we even care? And yeah, why do we want yet another security encryption thing? And more, not really how the protocol works, but more specifically how you can use it instead. So I'm going to start with an introduction to MaxX. In general terms, describe some environments that would be a good use case for MaxX. Then I'm going to show you a few other protocols that you could use instead of using MaxX. Maybe protocols you know a little bit better than MaxX. Then tell you some use cases for MaxX and for these other protocols. And I'll finish with a few configuration examples for practical purposes. So first, what is MaxX? And if you're not familiar with it, maybe. So what's X? It's an IEEE standard, 802.1 AE. It was standardized in 2006. It's for encryption over Ethernet LANs. It provides authenticated encryption that is both integrity and confidentiality for all your traffic using GCM AES with 128 bit keys. So it's a pretty solid encryption. Since you need to forward the frames, you cannot protect the source and destination MAC addresses, but they are still authenticated, so they cannot be modified by some man-in-the-middle attack or something. And MaxX also has a mechanism for replay protection. It only works, the most specific thing about MaxX is it only works within a single LAN. So it cannot go through any router that you might have in the middle. Because anyway, the IP addresses in your packet are not even visible. They are also encrypted. There's one extension to 802.1x that allows you to do mutual authentication of nodes and key distribution, which makes it more convenient to use. Otherwise, you have to do manual key exchange, and that really sucks. So let's see some environments and use cases that are a good fit for MaxX. I'm going to start with maybe the most obvious thing, which is a native LAN. And then I have two variations of that. One is if you have one untrusted link in the middle of your network, and one other use case is when you have a part of your network where you don't really know what's going to connect to it. So let's say you have one LAN, and you have, say, two buildings on either side of the street, and you have a link to connect them, and you don't trust the provider of that link, and you don't know where it goes. So you want to encrypt the communication that goes over that link. So that red link in the middle, you don't trust that. And you're going to set up MaxX between switch 1 and switch 2, and all the communication there will be encrypted. And now you don't care if the provider of that link is completely untrustworthy. Another use case is you have a link that you have a LAN that you're okay with that. You know what's going to plug into that. Maybe it's inside your data center or something, and you know this is safe. But on switch 2, you have some publicly exposed port, and you don't know host 3, 4, and 5. You don't know what's going to plug into your network. So by default, all these communications here you don't trust what's coming in here. And now let's say that host 3 and 4 have successfully started doing MaxX, and they are talking to switch 2. All the data that goes between host 3 and 4 and switch 2 is encrypted. And so that is going to be forwarded by switch 2 decrypted by switch 2 and forwarded to the rest of your network. On the other hand, you have host 5 that isn't participating in MaxX, it's not encrypted, it's traffic, so you still don't trust what's coming here. Maybe you don't grant it any access to the rest of your network, you don't want that. A kind of extension to that use case is if you have a cloud. Let's say you have a group of virtual machines that are hosted on OpenStack, for example. And what OpenStack provides you is a virtual LAN. So it's on the provider network, it's going to be some VXLAN tunnels and some stuff like that. But to you, it's just a LAN. Your virtual machines, that's all they see. It's transparent. You have your LAN. And you don't really trust the network from your cloud provider. You don't know where your packets are going to go in between when they're between your virtual machines. So you want to encrypt the communications, for example, between virtual machine 1 and VM2. Maybe VM2 is hosting a database that VM1 is using, and you want to encrypt that communication. Of course, you cannot encrypt the communication between VM1 and the users, like in the real world, because then they cannot access your services, but or not with MaxX at least, but between your virtual machines, you want to encrypt that communication, and you're going to set up a MaxX association between VM1 and VM2, maybe another one between 3 and 4. And now everything that goes between these virtual machines is encrypted, even DHCP and ARP, everything is completely protected. I'm saying virtual machines here, but it could work the same with containers because they will also have some virtual LAN, and it's basically equivalent. Now I'm going to talk about a few other protocols that, maybe you've heard a bit more of. I'll start with IPsec, which is kind of similar, but the most difference is it works at layer 3. So it's only going to encrypt the payload of your IP packets. The big difference here is it can go through any router you want, but it's not going to protect your DHCP. If that's something you're interested in, then you cannot use IPsec for that. IPsec provides various integrity and confidentiality modes, including the one that MaxX does, which is GCM AES. IPsec also provides replay protection, and there's a key exchange mechanism via IKE, Internet Key Exchange. IPsec also has 2 major modes, which is the transport mode, if you only want to secure a direct connection between 2 machines, or tunnel mode if you want to establish a VPN between 2 networks. Since we're talking about VPNs, there's OpenVPN. It's only going to protect your layer 4 payload. All traffic is encapsulated over layer 4, so it can also be routed. You can choose as an administrator whether it's going to encapsulate the L2 or L3 traffic. OpenVPN supports multiple crypto algorithms, but not GCM AES. Yes?
OpenVPN 2.4 has GCM.
Okay, I didn't know that, sorry. So there is GCM AES now in the latest OpenVPN release. I'm not up to date. There is also replay protection, and key exchange is provided via TLS. So TLS and DTLS, its datagram brother, will only protect your L4 payload. It provides integrity and confidentiality for all your data, and replay protection, and there's also a key exchange system. And now let's finish this overview with something a little bit different. D0207X provides port control. So it's only access control. There is no confidentiality, no integrity. There's no encryption at all. It's just going to tell basically if the port on your switch that you're plugged in is switched on or switched off. If you don't do the authentication phase, your port is switched off. That's it. So when do you want to use MaxX using all these ideas that you have now? So this is just an overview, a summary of the information in the previous slides. If you care about encrypting these layer 2 things, you will have to use MaxX. Otherwise, you have more choices. Naturally, if you want to let your encrypted traffic go outside of your LAN, you need to use something else than MaxX, because MaxX is never going to leave your LAN, or not until you encapsulate it over something else. So yeah, if protecting protocols below IP is required, then you probably want MaxX. And finally, the practical part of this presentation, how can you actually use MaxX in your network? So the first, most, let's say, bare bones approach is using IP route. IP route is nice if you just want to see how it actually works, because it's the closest approach to the actual protocol, but it's not very convenient. You have to generate your keys manually, and you have to feed them to all the hosts that you're going to use. So the first, you have to generate one key for transmission and on each machine that you're going to use. And then you set up a MaxX link on top of the whatever network interface you're using to connect to this network. You enable a key and a transmit association. And then you need, for each machine that you expect to receive packets from, you need to set up a receive association, a receive channel, and a receive association with the key corresponding to that machine. What makes it really inconvenient is that when your packet number reaches its maximum value, your key becomes invalid and you need to set up a new one, which is, again, set it up manually. So it's kind of nice if you want some quick fire thing, just set up a connection, transfer a few things, 5 minutes, you're done. It's a nice debugging tool, but it's not practical at all. What you probably want to use instead is WPA supplicant, which in the latest, in the current Git tree implements the full MKA, so MaxX Key Exchange Key Agreement Protocol. And that is going to generate some keys for you, do authentication between your hosts, generate some keys, configure the kernel, set up MaxX, and you don't have to touch anything anymore. So that's a sample configuration file. You have to generate one key, one connectivity association key, and one CAC number, that's the CKN. You need that pair. And then your WPA supplicant instances, all connected to the same LAN, are going to exchange some keys, are going to perform authentication, check that they are able to synchronize each other with that, and start exchanging keys for MaxX encryption themselves. So that is the, I would say, pre-shared key mode of MaxX. There's also a kind of more similar to Wi-Fi with WPA Enterprise, where you could use login and username if you have a switch that provides the authenticator part of that. So here, if you have this configuration file, then you just run WPA supplicant. That's, if you use WPA supplicant manually, it's similar to what you would do on Wi-Fi with the MaxX Linux driver. and that's it. As I said, it requires a very recent version of WPA supplicant, also of libnl, but other than that, it's going to be in a future release of WPA supplicant. Now, maybe something even more convenient to a lot of people is Network Manager. You will also have to generate your CAC and CKN. Then you can use NMCLI for that. And what Network Manager is going to do is set up WPA supplicant. It configures WPA supplicant for you, and WPA supplicant takes care of the key exchange in the background. And that will be part of the next release of Network Manager, thanks to Beniamino, who is right here in the middle. And that's it. Yes?
How well does it scale in terms of performance? Is it usable for 10 gigabit networks?
So is MaxX suitable for 10 gigabit networks? The last test I did was only with a single TCP stream, and I was in the 3 to 4 gigabits per second with one single stream. I haven't checked with multiple streams concurrently. So you cannot, at this point, you cannot do line rate on 10 gig with a single stream. But we're looking into some performance improvement. That's the next thing coming up. There's also offloading in a few, MaxX offloading in a few models of network cards. We haven't implemented that in the kernel yet. But there are very few network cards. You have to find the right one. Yes?
What switch vendors is this tested with?
What switch vendor? So right now I've only tested that with a Juniper switch. I think there are a few other vendors that have MaxX in their switches, but I don't have access to them right now. Yes?
Is some hardware support expected from vendors of chipsets in the future? For example, for applications with cameras and things like that, with small devices?
So do we expect maybe some IoT devices supporting MaxX? I don't know.
You know, because it's a big difference whether it is implemented on operating system level or whether you are having a hardware layer support.
So yeah, it is different whether the kernel has the infrastructure for that and whether actual stuff deployed in the wild has it. It's still the early days of this MaxX implementation. It's going to get, I hope, a lot more attention now that it's here, because a year ago we didn't even have a MaxX implementation in Linux. So hopefully it's going to gain some traction. Yes?
Do we need any special configuration on the switch side? Even if the switch supports the MaxX, does the network admin have to enable this?
So do we need some special configuration if we have a switch that supports MaxX? Yes, in the Juniper switch that I tested with, you need to enable MaxX on your port. You need to set up this connectivity association key on your switch, and then your host has WPA supplicant that synchronizes and establishes a session.
And you need the right hardware and expensive licenses.
Yes, you actually need a license for that. True. Yes.
When you configure MaxX with IP routes, there is an option encrypt on and encrypt off. I'm wondering, is this usable
So what's the purpose of having encrypt on and encrypt off? If you have encrypt on, your traffic will be encrypted and authenticated. With encrypt off, your traffic is just authenticated, but the packets are transmitted in the clear, like authentication header in IPsec, kind of. Yes.
Does that carry a significant performance increase if you turn encryption off?
In some tests that Jan did, there was a performance difference. I don't remember how much, and we haven't investigated yet if.
It's small somehow. I'm not sure. There was a difference.
Yeah, there was a performance difference if you're not encrypting, but I cannot tell you how much right now. And we will check if that can be improved too. Yes.
You mentioned OpenVPN, but didn't talk about LibreSwan. Is that just an addition, or have you looked at LibreSwan and compared it to
Oh, but LibreSwan is just for IPsec, right?
Right, but you listed OpenVPN as a comparison. So
Yeah, because it's kind of separate and it's a separate technology compared to LibreSwan, which is IPsec. But yeah, I could mention LibreSwan and OpenSwan and the others that I forgot when I mentioned IPsec. Sorry. Yes.
Does Linux Bridge support MaxX?
Does the Linux bridge support MaxX? The Linux bridge itself doesn't really care about MaxX. You can either do MaxX on the ports that you plug in your bridge, or you can do MaxX on top of your bridge. So create a MaxX link. Instead of using ETH0, you use BR0 or something. Yes?
How's the plans for RHEL?
For RHEL, what plan do we have for MaxX in RHEL? MaxX, the kernel and IP route part are already in 7.3, and the WPA supplicant and network manager are going to be in 7.4. We have absolutely no plan on putting that in RHEL 6, sorry.
what about the layered stack? Is there any plans with like OpenShift, OpenStack, and others who are actually consuming the operating system to start utilizing something like that?
So what about integration with OpenStack and OpenShift? If you want to, well, it depends. The most valid, in my opinion, the main use case for MaxX on OpenStack is from the tenant's point of view. And so set it up within your virtual machine. And I would see that using network manager in the virtual machine. We don't have any plan yet to enable MaxX on the OpenStack itself from the operator's point of view. But we can, if someone shows me a use case for that or request to enable it, then sure, we can talk about it.
Well, the question is there a use case, right? Maybe yes, maybe no, I don't know.
I don't really see one, but
okay.
I see mostly MaxX as from the tenant that doesn't trust the operator, more than for what would the operator do?
Can be a legal requirement. Why to use MaxX?
Well, use an encrypted network. I don't think requirements specify how you encrypt.
If this requirement comes, then we can talk about it. Okay, Oh, quickly.
How much bigger is a packet encrypted than a common packet? If I have a packet with max MTU 1500, what is encrypted packet MTU?
It's something like 20 extra bytes. 20 up to 32, I think. Oh, what is the overhead of MaxX on the packet size? You have a 16-byte authentication tag and 12 bytes header or something. Yeah, pretty small. Okay. Thank you. Thank you very much.